Let's now run open source models for free. We're currently on the second of 3 steps. We're now trying small open source models. For now, let's treat Llama 3.2 8 billion as our default. This is a tiny language model that should fit on your laptop. Of course, there are many other open source models, but before I discuss those, the next few slides will refer to a few terms like GPU, node, RAM, and precision. If you're unfamiliar with those terms, you can safely ignore my explanation and just focus on the takeaway. I'll also include definitions on the course website at this URL. Now, back to rule number 2. We previously said to use small models, but let's be more precise about what small means. By small, I mean single GPU models, which is way simpler than multi-GPU and especially multi-node for inference. Now that we've narrowed down to single GPU open source models, which open source models fit on a single GPU? Well, that depends on 2 factors, the RAM your GPU has and the precision of your model. I'll put the full explanation on the course website, but for now, we'll say that LLMs with 16 billion or fewer parameters can fit on a single GPU. Let's use this to find an open source model to use. Back on Hugging Face's website, on the left-hand side, filter by model size. We want 16 billion or fewer parameters, but 12 billion is the closest value we can use. Then in the top right, sort models by likes. After both modifications, you'll see a page like this. Looking at the number of downloads, we quickly see a winner. Llama 3.1 8 billion Instruct, which had over 9 million downloads in the last month. Let's use this model. For our open source experiments, we'll be using an 8 billion parameter model from the Llama family of LLMs. This is one of the most downloaded models over the last month from Hugging Face. And more importantly, we've determined that this model fits on the GPUs we're using. Go to this URL to open the starter code that I've written for you. You should see a notebook like this one. Now at the top of the file, click Run All. You might see an error. If you see an error like this, then you'll have to run each step manually. To run manually, move your cursor so that it hovers over step 1. A Run button will appear, click on that Run button. After this, even though step 1 is still running, you can immediately hover over step 2 and click on its Run button. Then you should see dotted lines like this, indicating step 2 is queued up. Whether you hit Run All or ran the first steps manually, your notebook is now installing prerequisites and downloading weights. This will take 5 to 10 minutes, so during that time, continue watching this video walkthrough. After a few minutes, step 1 will finish. If you see a green checkmark, that means step 1 completed successfully. After a few more minutes, step 2 should finish too. Again, you should see a green checkmark, indicating success. Now, whether or not you've already run step 3, next to step 3, click Run. After a few seconds, we'll see Llama's outputs discussing the meaning of life. You should now see the prompt. You should now change the prompt to whatever you desire and hit the Run button one more time. Treat this as a personal chatbot. You can ask or say whatever you might normally say to ChatGPT. For example, we can have Llama explain some math to us, or have Llama tell us about our favorite online learning platform. This is effectively your very own AI running in the cloud. No one but you is using this dedicated LLM. Now it's time to test Llama on our example project. Hit Run on the last cell here to test Llama's ability to identify non-food critiques. But unfortunately, Llama gets it wrong, saying both the first and third reviews are true, that they are both non-food critiques. In other words, Llama predicts true-false-true instead of true-false-false. We'll fix this in the next lesson without training the model. And that's it. We've now run our very first open source LLM. And now we've finally finished the second of 3 steps. As I mentioned before, our next step is to refine quality. In particular, we'll improve this open source LLM's ability to complete our example project.